Hello everyone, this is Dave from Solar on the Cheap, and what I have here today is a model that I put together to try to simulate what the panel is going to be doing in real life. This is a piece of drywall with a dowel, and I have a rod pasted to the back of it to simulate the rotation of the panel from east to west. My intention is to rather than have a fixed panel up on the roof. By tracking the sun, you can get 25 or 30% more power out of it. That means instead of having, say, 3 large panels, you only need 2. You need 1/3 less. So the first decision you have to make is whether you're going to have a fixed panel or one that tracks the sun. And I've decided that I'm going to try to track the sun, at least for my initial experiments here. I have nothing better to do with my time than build little models, but actually I do have better things to do with my time, but the models help me visualize what goes on. You may have seen another video of mine that I had this on a tripod to try to track the sun, and I don't think it's simulated what exactly we're going to do. I have 2 pivot points that I'm going to connect the panel to, one at the top and one at the bottom, or it could be sitting on a single pole and still rotate. Well, in this instance, it's going to rotate. I have a fixed angle at this point, but from east to west, I'm going to allow it to track like that. Now, there's different ways of tracking. There's different trackers out there. The thing could track like I was just showing you, or it could track like this in addition to turning like this. You know what I'm saying? So it can get kind of complicated, so I'm trying to keep it as simple as possible. Basically, this angle that I have it set at here, let's see, alright, 51.5 approximately is what I intend to have the panel fixed in the winter months, meaning from September 22nd to March 22nd. I intend to have the panel fixed at this angle. Alright? Then on March 22nd, I'm going to change the angle of this panel to something like that, which is 27.5. Alright, and it's still going to be able to track the sun from east to west. Now, the reason I picked these 2 angles is that in my latitude, which is 39.7, that is when during the spring and fall equinoxes, that is the angle that the panel would be sitting at, 39.7. During the summer solstice, it actually goes up to 16.1. So that's what the panel would look like at the full extreme. So I intend to split the difference and set the angle between the summer solstice and the fall and spring. I'm sorry, yeah, the fall and spring equinoxes. And like I said, it's 39 degrees for the equinoxes, and it's 16.1 and 63.3, which is, you add and subtract 23.6, which is the angle of the Earth, and you get those two values, 16.1 and 63.3. So I took the difference between those two extremes, between the summer solstice and, say, the fall equinox, and it turns out to be 27.5. So I'm going to leave it. So what I'm trying to do is, actually, the whole purpose of this is to see how far this panel needs to rotate. Let me bring it back down. Alright, I want to know, I'm trying to find out at what angles, when the sun comes up, say at 9 in the morning, what angle is this panel going to be at? And then as it tracks across, that'd be about noon, and then around 3-4 o'clock in the evening it's going to be something like that. And there's a tracking device hopefully I'm going to be hooking to this. Now this is just one panel. I'm going to actually have four panels on a I was going to do it with 2 poles. I was going to put a pole at the top and a pole at the bottom and spin it on that. But I think I'm going to change that and go to a tripod with a single pole coming up the middle, but it'll still pivot exactly like that. Okay, that's how I'm going to track the sun. It's not precise because, like I said earlier, a better tracker would probably rotate it and angle so that you're direct perpendicular all the time. But that gets a little bit compounded. It takes a compound tracking device, and I'm just going to go with the single. I'm just going left to right. That's it. Okay, and then I'm going to fix this angle up and down. So what I'm going to do tomorrow, or the next video, is I will 51.5. Like I said, it's not quite 63, but it's not 39 either. You know, so it's in between 63 and 39.7, midway. So what I'm going to do is, in the morning at 9 o'clock, hopefully, if the sun's out, I'm going to measure the angle. Let's see if I can get this picture here. Something like that. Anyway, what I'll do is, around 9 o'clock in the morning, which is when the sun clears the trees, I'm going to measure this angle, and it's probably going to look something like that. Let's see. It says 53 or so. Alright, and then we'll see tomorrow morning at 9 o'clock, and I'll actually record that every hour. I think what I'm going to do is every hour I'm going to track it so that I have an idea. So I just have some data, and then that's about 53 degrees that way. So and I'll do it. Today is January 7th, a little bit past the winter solstice. So I'll record the date, and I'll record my angles as I as each hour passes. Alright, so I'm going to use this model to collect the data, and like I said, I'm hoping that on top of a tripod it'll pivot just like this, left to right, and I'll have some good data. And yeah, so that's it. And so by the way, there's the panels. There's one of them anyway. There's another one behind it, one I made up, and that's all right. So I have 2 panels at this point in time, and I'm going to be making up a tracker that I'm going to set these on. I could have put these on the roof, but I don't feel like climbing up on the roof. It's the middle of winter, and I thought that I could set up a little tracker outside and collect data that way, and we'll see how it goes. Alright, so that's it for now. I will let you know my results. Bye.